right? But ideally, that looks totally like the AI is attacking us and actually hitting us, right? Legitness. Okay, so I wanted to do, and I'm going to link a GitHub project. There is a tutorial out there, and I'll link that tutorial because they do a wonderful job on 2D navigation. And in their tutorial, they show you how to, or where to get it, how to download it, how to install it, and how to set it up. So I won't cover too much of that. I'm going to work more on the AI. But essentially, we need a navigation object, and what else? We're gonna do it with a tile map. So let's create a tile map. Actually, I need 2 tile maps. So the first one is going to be like a background. And I'm just going to grab anything like that. It doesn't have to be square, by the way. And then I'm going to grab this one, and I'm just going to paint some stuff. So the AI has navigation. It has to go around things, right? Yeah. So let's go over. Okay. I'm going to take this camera on prefab, this guy, and I'm just going to put the camera in him. It's not the best way to do cameras for sure, but in my case it will work just fine. Where's my camera? Oh, I put his like distance like crazy far. I'm also going to put the camera to orthographic for this. Zoom out a little bit. Alright, so here I have a unit, and we have a tile map. Let's go back to 2D. And with the tile map, we need colliders. So let's put some tile map colliders on. I'm also, because I have the background as a collider, and you don't have to keep the collider on, but I will, I made a layer called ground. And this unit is going to be on layer player. Now the important thing with this is if I go to my project settings and go to physics 2D, ground and player can't collide. So the fact the player is kind of inside this collider is fine. Where this collider is here, so I can't collide with that. I can collide with this one, can't collide with that one. So let's add a modifier, Navmesh modifier, and we're going to say override area, and this one's walkable. Let's copy that. Let's add one to this side. Again, override and not walkable. Alright, so the Navmesh needs a Navmesh surface 2D, which is what you get in the GitHub package. I'm going to rotate it, and now I'm going to take the grid and child it to the Navmesh. So I can go to the Navmesh and say we're going to collect our children, so everything here, and we're going to base this off of physics colliders. We're going to bake, and we have Navmesh in a 2D world. Cool. Pretty cool. Now, here I have a player, and I've kind of preset him up. So he's got 4-way inputs, right? And if I hit play, like he doesn't actually move. He plays his animations and he can attack, but he doesn't actually move, right? And all it is yeah, he can face different directions. Apparently my attack's no longer working, or it's because of the other thing is because I'm dealing with the tile maps, I'm going to want to put my background like low. my walls. Probably, let's put the walls up a little bit. Let's put it like 10. Let's go crazy high. Let's make sure our unit, he's on 0, which is fine. So he's in between. So he'll render over top of the ground. He'll render underneath the walls. There we go. Now we have, yeah, so as you see, like, he doesn't actually move though. So we got to fix that. Yeah. So let's just add an FSM. Help if I'd spelt it right. And I'm just going to add a get FSM or get axes vector. And I'm going to add a rigid body component 2D. Take gravity scale off. We're going to store our vector. And then we're going to get XYZ. And we're going to set velocity 2D. There we go. So we're going to say get the XYZ of these. We're going to get the X and the Z, which will end up being the Y, because we have to convert it from 3D to 2D. And let's move this to the top and move this to the bottom. Get this all organized. So we want to move X and Y and every frame. And we can probably up that speed to like 4. And we should now have a very simplistic way of moving. Right? Can attack, go up, just truck along. Oh, we have some issues here. We gotta fix that because we do not want to be able to go through that. So let's see. Our wall is on default. Our unit has no collider. Well, let's just fix that up. There we go. Now we have a collider. It's massive. Let's bring that down. There we go. You know what? And I think I'm going to take his weapon here and I'm going to put it to like a, I'm going to put that to like a 2 and put him on a 3 and bring this wall down to a 1. So that it looks kind of funny when I swing it and it goes into the ground. Maybe that's what you want. I don't know. Right, so now we, can't go through it. Whoa! We gotta fix all that. So we obviously don't want him spinning. So let's lock his rotation. Okay, but now we have a little miniature player that really is poor. I'm going to duplicate him. And this guy, I'm going to pull out the movement I just made on this one and my input. So that's what's actually moving him. Because the rest of it's based for his animations based on a vector. Actually, so it's not based on any input per se. So you have a couple different options you can do with Navmesh here. So if we just threw a normal Navmesh agent on him, and it looks kind of funny, and we bring the radius down a bit, there it is, something closer to that, and then technically just from there with this navigation the way it is, because we're using Navmesh, right? We're not doing some crazy other system. It's your basic Navmesh, and I could tell them to chase the player. Right, right? And he is all screwy. That's going to be to expected, but it is working. Like he wants to move around. Okay, so let's fix him up so he doesn't get all crazy here. And what we got to do is we need a couple things. We need to, in a start state, I'm going to drag the Navmesh unit in and say update axes, turning that off. And then the other thing I want to do is, it's an action, is update rotation and turn this one off. So now he'll actually stand in the proper form. And we have this AI. Now for how I built my directional, let's not use that. Let's make a new FSM. Right, I technically could get agent velocity, right, and we get a velocity which will act just like my input system that I had there, and it would say to supervert very basic, set FSM vector 3 and float. So into our control, I have magnitude. Set that to mag. In our control, we also have movement variable. Set that to velocity. Because really all you do in the movement is you extract the X and the Y. And you know, if the X is negative or above negative 0.7, you're moving left. If it's below, or you're moving right if it's above negative 0.7, or above 0.7. If it's below negative 0.7, you're moving left. Got them all stuckered. Should bring his Navmesh agent down a bit on size, but he is working. Now, that's all cool and all, but what if? Oh, you know what? He has a camera. I should probably get rid of that camera. What if we wanted for him to be able to say bounce off of walls and stuff like so? He has a collider. Now if I pull the Navmesh agent off and create an empty and put the Navmesh agent on the empty, right, and again bring the radius down, so forth. Okay, so in our init here, where we set properties and so forth, that's going to have to now be on, whoops, property want is that thing. Let's update the rotation like that. So now the other thing we're going to need is update position. So we want this guy's position to also not update. Now what happens when this happens? It kind of decouples your Navmesh agent to your object, and you get this funky we have to actually tell the unit to go do something. So our Navmesh unit is this guy. So because it's decoupled, it won't actually move our AI. It moves the Navmesh agent. Does is why you get this little thing like, so okay, that's traveling, and that thing's going to follow me around. Like that's the Navmesh agent. So our actual characters are standing there. You're probably thinking like, why the hell would you want to do this in the first place? And the very simple answer is, if I add an FSM, and in this FSM I say get position, we'll get those two positions. We need two of them. So we have our position every frame. We have our AI position every frame. And then we say, okay, well, let's take our position, might have that backwards, we'll find out. We'll subtract them every frame. We get a difference. And then I'm going to agent move. Now, this action, I believe, isn't an every frame thing. So you need to make this every frame for this to work. To do that, if you right click and edit the action to have this little thing here, it's opening. It just, scripting always takes a while. It's one of the benefits of Playmaker, actually, is the fact that we don't have to compile and do all this crap. So this is what your action looks like on the inside for the agent move. And all we have to do is add a public bool of every frame right up here in this area, and then see on enter. So this is what gets called. It gets called once. So normally we would do this thing called move, and it's moving stuff. We don't need to worry about that. But then it says finished, and it ends it. So I just added this little line here saying if every frame, but I put an exclamation mark in front of it, so it's saying if not every frame. So if it's false, right? So if it's false, then we'll finish. So it's just normal. But then I added a public override void on update. So this gets called every frame. And it's the opposite. If every frame, but it doesn't have the exclamation mark. So if it's true, do move, and this gets called every frame. And that's the only difference. That's all I added. And it gives me the option now to convert this action into an every frame action. So you're probably wondering, why the hell are we doing this to begin with? Well, the beauty part about Navmesh isn't so much the agents, it's the factor that we can calculate a point to another point. And that's all we need to do, right? So now that we have this, right, even telling the agent to move and chase this guy, he can't. Oh, despite that, apparently he can. Let's see what's happening here. Why are we not? Where is? Oh, right. So let's go back to our init. I am gonna. We do want him to keep his position. Sorry about that. Because we're going to use this guy's vector. But you see how he's standing still. He's technically trying to chase the player. Like this got called. Where is it? Right. So he wants to chase the player. We can't. He's stuck there because every frame he moves, there's a difference between him and the root. We calculate that difference going backwards and say, okay, move the opposite direction. So he wants to move forward. We're telling him to move back. That's same, well, I guess the opposite. So he's technically now not moving, but he wants to move. He really does. You're probably thinking, okay, well, that's weird. Why do that? Well, now that we've done that, I can do this neat little thing called get agent. I don't know if velocity will actually work. Normally I would just use the get steering path, but we'll try the velocity. So let's get the velocity. We'll just call it position. So normally I use a steering direction, but we'll see if the velocity works. And velocity, we can also get magnitude. Oh yeah, so the velocity works just fine. So ultimately the agent wants to go left and tiny bit up, right? Which makes sense. All right, so there we have a velocity that this agent wants to do, but the agent's stuck here, but he's trying to get to our player. How does that help us? Well, now we can set FSM vector 3 into our little control unit that takes a vector thing to actually move our guy, and that can now give us our animations. Or it should. Let's see. Unless we have something else also controlling that, which I think we do. Yeah, okay, so this one here, we got to turn this one off. Right, because I have this same kind of thing happening here, but we're not using that one. Get rid of that one. All right, so now, so like I said, now we're getting where the agent wants to go, and it's gonna just go the, but now he has physics. I can actually bounce him around, right? So let's adjust his physics, because it looks weird if you just kind of give him some drag. And I don't know why he doesn't go up and down. Oh, that's because in my system here, I pull out the X, Y, the movement, and I'm using the Z because that's what it was on the player, right? Because in the player, getting axis vector, you're using X, Z. We're not in this situation, we're using X, Y. So I'm just going to put those into X, Y for the AI because we're in a 2D world and he does 2D calculations. All right, so now let's see. He should have the up and down. Apparently, he's making a liar of me. Oh, we have an issue here. Oh, yeah, okay, yeah. So this is one of the other things that I have to do is we're getting a velocity, right? And that's all fine and dandy, but in the control system, because you have to deal with X and Y, because you have the 4 different directions, because we're in a 4-directional map, is we take a vector and negative X is left, positive X is right, Y is up, negative Y is down. So to go on an angle, we don't want, like, how do you calculate which way you're going? So what we do is we normalize a vector. So if it's going up, it's 1 on the Y. If it's going this way, it's -1 on the X. But if it's going up in an angle, we don't want it to go 1 and 1, because how do we do a float compare on that? It doesn't frickin' work. So we have to normalize the vector, and it'll do that for us. So all we got to do is right there, just add a normalize in after the velocity, but before the set vector. And it'll normalize this vector. So now we have -1 and 0.2. See now how he is facing us just fine. Perfect. So let's actually give him some directional. And we could, right in here, if we wanted to, you know, set velocity or add force. Add force would probably be a funner method to do, but I do not wish to do that at this exact moment in time. So we would need, okay, so I gotta extract get vector XYZ. So let's get the X, and we're gonna get the Y every frame, and set X and Y every frame. World, we'll probably need to multiply that. That's okay. I'm not worried about it right now because I'm going to show you another method here in a second to be a little more traditional. So now we have this AI that is moving. It's slow because he's only using a speed of 1, but he's also physics. So he can push me, I can push him. So if I was to swing my weapon, and if it had physics on it, I could bat him around now if I wanted to, right? But he's got full navigation, right? He's going to slide around, go around. So we now all of a sudden have this nice little stuck there, but there's things to do about that we can fix. So that's, but that's kind of like a nice basic physics 2D AI. So what if we get rid of our little movement that we just added, and instead let's go up to where I have our control. So like I said, now with the control, the way I did the control here is we get a vector, has to be normalized, and then I'm just comparing. Like I pull out its X and its Y, and I compare the X, compare the Y's, and depending on what it is, we're either going to go left, right, down, up, or it's nothing and we can sit and idle. And these things just do the same thing. So there is actually no logic in here. It just bounces around and changes states. While I have another FSM that actually watches the first FSM and it checks the name of the state. And it says, whoa, the state isn't the previous state, it's changed. Comes down and says, okay, what state are we in? Up, down, left, right, or idle? It says, okay, we're up. Let's set our animation to play. We have to do it on, so we're going to say we're going to start walking. We have speed. We're going to set our new current state. We're up. And then we also tell our weapon that it has to change as well. So that's why it's sitting in there. So if we hit the attack button, it plays this animation, right? And then if we go to the left and right, it also has the sprite flipping, right? So this just kind of sets our parameters for how we want this system to work. But we could, up here, for example, set velocity 2D if we really wanted to. If this is left, say -2. Well, let's make that every frame and then copy it. And if we're going right, let's go 2. And if we're going up, let's go 2 there, 0 there. And if we're going down, 0 there, -2 there. And now all of a sudden we have four-way movement on our Navmesh 2D top-down AI, right? You can only move in those 4 directions now, right? A little more classic, a little more traditional, right? He doesn't have the infinite move. Now, let's say you have to kind of adjust some sizing there on the a few of the things. So if I look into my navigation, right, because he wants to go here. That's where he's wanting to go. He's getting stuck. So, I mean, collider-wise, he needs to come down a bit. This collider is way too big to start with. And then the other thing he's going to need is, see how thin that is? We need to make that thicker. Right, so we would need we need to rebake that nav mesh, but we need to change our agent sizes, right? So if we go to our agents radius, he's at 0.2. Let's go take that up to a 0.5, and let's bake that. And we should see this expand out a bit. Hopefully we didn't go too far. And like I said, the collider needs to come down in size. But that should now allow, so he won't get caught on those corners. The other thing we could add is actually a physics material to his collider and add him a little slide. Right, but see now he's, yeah, see how the nav mesh agent got pushed a bit there? Right, so he'll now work a lot better. He won't get stuck on the walls. So it's just a matter of tweaking a few things. Pretty simple. Oh, he got stuck right there though. That's for that. Again, though, his collider's here and his nav mesh is there. It's just a matter of going to this guy, and we can adjust the base offset so it actually matches up with his collider. Right, something like that, because it's his collider and his nav mesh were in 2 different spots. So a little bit of tweaking, nothing crazy. Now with that, you also could, in reality, so we set velocity every frame. You know what? We could do a wait. Delay. Send the delay, no. And if we just kind of add a little bit of a delay, so he can only move for, you know, half a second at a time, and then maybe a half a second stop. We can get another effect on our AI that, again, it might be, it's kind of a little more classical, nothing you know, high-end crazy, but you know, it's good. It's depending on the style of game. Right, so let's add our delay events. And like I said, so now technically he can only move for half a second, and then he has to pause for a half a second. Oh, I see one minor issue there. Oh, that needs a finished, not a delay. We also want to set velocity in our delay state, but this one's a 0. But now he'll have that kind of that stuttering movement. It's kind of more, you know, more old school. Right, and you can adjust the times for how long he's moving compared to how long he delays. You could change that delay to only happen when the player moves a certain amount or something, or on that, and maybe a global time or something like that, right? But there we have, oh, I screwed them up somehow. Okay, so Navmesh wise, and his moving, right? So the movement system's working. So the other thing we're going to want to do now real quick is not have this FSM, or let's rename it and take this crap out, right? Because now what if we get position, and this is our starting position. We finish, we come over here, and now we have we can do this, or we could do trigger as well. But if we did, no, I don't know if I want that. Let's look at our 2D physics. What do we have for options? Collision events. I suppose I could do it that way. Well, let's do it this way. I'm going to add a circle collider. Where is he? Where is he? So he's there. Let's add this as a trigger and make it bigger. Something like that. Let's go to our brain. So after we get the position, we can just do a trigger event. 2D. And if it hits a player, we are going to attack our player. Who is our player? Our player is that thing that's triggered our event itself. So what do we want to do now? We want to set agent destination to whatever triggered this thing to begin with. Now we can do some distance testing to find out when we should attack. The other thing is we could probably do a get distance 2. So our distance to our starting position, we'll say distance from start, we'll compare, and if distance from start becomes greater than, we'll say 10, I don't know how far that's going to be, that might be way too big, go 6, oh wait, distance from start 6. So if we are greater, let's go back. There we go. So now the AI is going to sit there and do nothing. Perfect. We could always add in a bit of a wander system to them. Right, and if we come into the trigger, and our guy needs to be marked player, so that would help, because we said filter by tag and then we didn't give him a tag. So now does our player have he does have a capsule. Player. This guy is got, where's his brain? And oh yeah, okay, I totally messed that up. I'm just so used to that. So we want his AI to travel to that target, not him. Just one of those things you gotta get kind of used to. Is you're not dealing with the one unit, you're dealing with the unit and his child, the AI, right? And if we go too far, now he doesn't actually move back, but he should come out of this state, right? So yeah, he's so now he's still technically chasing, because in this stage he doesn't do anything. So let's set agent destination of our AI unit to go back to our starting position. And now we should have something a little different. Right, because he's going to chase, and if we get too far, he's going to start going back. Now, as fun as that is to watch, I am going to take the delay off so we can see it a little clearer. Now put these weights in. So the system's not fully set up for that kind of stuttering movement, but it is there. It does work. Alright, so he's chasing us, and if we move too far away, he decides to turn around and go back to wherever the hell he came from. Alright, now he's kind of doing this weird loopy stupid thing. Let's give him a stopping distance. Something like that, and that should rectify that issue. So he goes back. Alright, let's see what he is doing. I mean, he's a little loopy there. So we'll see why. Alright, so like this kind of hopping back and forth. Let's go into the brain. Right, because he wants to sit there and he goes there, calls it good. This thing's just going ballistic. And if we getting his velocity. So okay, let's change this velocity. said normally I use steering target for this type of stuff, but whatever. Velocity I figured would work. Maybe it doesn't. And the steering target's just saying, okay, the AI wants to go here, right? Compared to getting the actual physical movement of the. I mean, you could still use the velocity for stuff. Why is he all crazy? No, that's not nearly as good. At least not the way we have it set up. You know what? Screw it. We'll just leave it for that. For now, so we smooth it out later on. All right, so we have AI and he can chase. It's 2D. I mean, he doesn't attack or anything yet, but if we get too far away, he runs back. See, I think his unit not his brain, in this guy. I think because I'm setting velocity here. In the idle states, I should be setting velocity to 0. Probably doesn't even need to be every frame, even if it's just once. I think that will, yeah, that'll get away from me, evil AI. So I think it's that sliding thing that's causing him, yeah, because that's a lot better. All right, cool. So let's just show a quick attack. So on the attack, I literally just play an attack animation. Now the attack animation is controlled by which direction we're facing, right? So we're going to play different attack animations. So when it comes to the AI, we get to his brain, right? So we have this kind of thing, and let's extend this out a little bit so it goes a little farther. And then let's also get distance again, only this time we're going to go to our whatever triggered our thing, and this is going to be a distance to target, and we can do another float compare, paste after. So if distance to target is, say, less than 2, we want to do an attack. We do an attack, and I should change that to actually match the proper thing, to which all I need to do is send event to myself, the attack, call attack, do a wait, you know, for maybe a second, and then just slide back in. Then on the actual attack, we could always run a animation event to trigger a check around our AI. Right, so now he's chasing us. I should speed him up. And he gets a little closer and he wants to attack. Nope, we ran too far away. You can always make it so if it's a distance to the player, right? So it's not. So he doesn't do that. That might be a better option, or to have both in there, right? If the distance gets really excessively far from the starting point, maybe go back. I don't know. So let's do distance from start. Let's do distance. Actually, let's get rid of. Yeah, okay. Let's do that. So if the distance gets like crazy stupid, we'll go back. But then let's bring in another float compare, and distance to target. If we get 8 from the target, if we're greater than that, let's also go back. So if we've traveled 20 units from our starting point, we'll go back, or if the player is just flat out super far away from us, we might as well just go back. Right, so now like he'll chase and chase, but if we push too far away, he'll go back. Now the one thing I think I would change in his, this guy is not trigger enter but trigger stay. But with that, you would have to throw in on the go back probably a next frame event, because you could have the situation where you're super far away and you're still in the trigger. Very cool. So that's kind of like the basics of attacking, right? And like I said, now you could have so the weapon's the one that's actually doing the animation. So from here we could do animation, and at said point, send event hit, and he have it down. So same idea, might as well send the exact same event. Idle, or no, that's side. Alright, so same thing. Up we already have. Right, so now we have this guy can now catch an event called hit. So really, in this situation, like I mean, we could cast an overlap sphere to see if the player's there, but I think I would just get FSM game object from our parent here, from our brain, that's our target, and get distance, and if distance from us to target is low, don't need it every frame, float compare, move to the bottom. If say distance is still below 2, cause damage, to which then we could send event. I don't have any health things set up, but hey, we can pretend, why not? Let's say we have a FSM called health and we send an event called damage, because I'm pretty sure I have that from 50 other tutorials. There we go, damage, and call it good. Alright, I'm going to make sure I'm going to put this one in action sequence, because I want to make sure that happens. And in here, if I said I'm hitting a FSM called health, and I have an event called damage, from here I can, let's say color, animate color. Yeah, let's animate a color. And set sprite color. So I'll move him down every frame. We need a color variable. So now we just need to animate that color variable, and let's say set value of the red let's just add a flash. Bloop. Kind of like that. So essentially our red should go 1 0 1 0, something like that. I mean, it's obviously not pinpoint accurate, but you'll get the idea, right? We can add a time for how long that's supposed to be, and that's it. Let's see if that works. And you'd also play sound effects and blood effects, maybe a knockback, right? Oh, we gotta make sure to set his color back to white. Right, because at the very end, White is I thought white. I thought everything was 0, but maybe it's 1s. Yeah, let's just leave it like that. I always get that backwards. I always mix that up. My whites always become black. My blacks always become whites. So we walk in here and he, smacks us around. And we're not adjusting our reds. Okay. We adjust our red. We didn't adjust our... Because right now our color is... Where's our sprite? Is white. And white is... They're all 1s. So let's just... set value blue. Let's set those all to 1. Alpha. We could always flash an alpha. So in here, I'm going to actually add a key onto these ones and bring these down so it actually turns red, not some weird tainted color. There. That should look a little better. Again, you could sit there and play with the animation curves and stuff like that for hours, tweaking that up. I don't want to spend that time right now. Oh my god, now we got blue happening. But why? Could have sworn. The red goes up. Set value. Yeah, because at the end everything's 1. That's, I don't know, weird. Oh, you know what? Like, these are all like... I didn't open up those graphs very far. That's the problem. There's only... bottom's only at 0.95. Right. Let's see now. If I was to line those up, the colors would look a little better, but I'm not worried about it that much. Right, but ideally that looks totally like the AI is attacking us and actually hitting us, right? Legitness. Right, looks good, right? So, I mean, even if he swings and I move away, it's totally dodging him. Oh, he got me there. But yeah, so we have this little AI, and he is beating the shit out of me. My collider is freaking massive. Totally going to shrink that down, right? So, and then from there, I mean, if we change it from the set velocity to use add force, but then you have to clamp your forces, you could really add some nice knockback effects on the player and the AI. But I won't get into that. I think that's probably good for a video for now. I mean, we have an AI. He can chase the player. You've seen a couple different ways that we can move him. And how he attacks. I mean, he's pretty basic. I mean, if the beauty part about the Navmesh is because we're using Navmesh. If you look at any of my other AI videos where I do wanders and patrols and stuff like that, all of that logic would work in this 2D environment using this system, right? Obviously, anything to do with the Z-axis has to be the Y-axis, but beyond that, I mean, everything's pretty good. And if you're curious a little more in depth on how I'm actually doing the animations, because you might be, let's take a quick look. Apparently he doesn't want to show up now. I don't know why. Where the hell's my animations? That's weird. Maybe because I had the animation tab open, which is weird because I've had it open lots. Alright, well, there we go. It's back now. So in reality, like I said, like I didn't even link things up, right? We'll have the attacks, 3 different attacks. None of them loop, but they're not linked to anything. I'm not even parameter-wise. I don't. And this should have been a bool, not a float, but whatever. And there's 3 attacks. I'm just controlling them by name. Same here. We have walk and idle, walking to the side and idle, walking down and idle, right? And they go up and down to that one float, right? So animator wise actually seems relatively simple. Now with that said, the weapon has its own he has an idle off animation, which is just him being his render being deactivated, but he just does the attacks. And again, there's no parameters. I'm literally just using names. So like I said, in the control, we get our movement vector, which can be from anything, right? Like if it's a player, I can take a input axes and give that to this system. If it's an AI, you could take the agent velocity, like how we're doing right now, and give it to the system. It doesn't matter. It just wants a vector for movement. So once it gets that vector, it pulls out the X and a Y. Now if it's an input axes, you're pulling out the Y or the Z for the Y, not the Y for the Y, because the endpoint. Never mind. So, anyways, we take those and we just calculate. Now normally you'd want to go 0.75. Because you're dealing with a normalized vector. So at 0.75, if it's greater than that, you are going that one direction. Right? So like I said, normalized vector. Because 1 is all the way one way, going any which way, but halfway will be 0.7. So if you're above 0.75, you are favoring one direction more than the others. So we just compare those 4 values, and we do that in all the states, right? So in this one, I compare the X and the Y, where in this one, again, I get the vector again, exact same thing. I've got these ones set right with 0.9s. But this one, I'm only doing the X on the negative and the 2 Y's because we're already in the right. I don't want to be testing, see if we're going right if we're already going right. So I'm only testing left, down, up, and then I'm also getting now the vector length. So how big is the vector? And we compare, and if it's low, we're going back to the idle state, right? And all these do that exact same thing. But it's this guy that actually controls the whole thing. So we're just looking into the state, and we're getting the state, and we're using a state name variable. So I defaulted it to down, and that's just by going like this and typing down. And then if it's not down, right? So if one of these states is changed, and if it's not down, this guy runs. He says, okay, grab the state, where are we? If we're going up, set our speed, because obviously we're moving. We're not in the idle state, which is why you could be using a bool for this instead of a float, but whatever. When I was making it was different. So we are moving, play our animation, walk up. Set our state that this thing's checking to up, so it knows that we're up. Tell the weapon to use, if the weapon's going to attack, to use this animation. And then it goes back and it waits. Now this would say up then. And if up changes, it says, okay, now where are we? Let's check all this stuff. And it says, oh, you know, you are here. Let's, you know, make sure our speed is 1. We're now going to play the walk side animation. We're going to set our state to left for checking. We'll set our sprites in our AI and in our weapon. And we tell our weapon if it's going to attack, this is the attack you're going to use. And then it goes back here and it waits. And if it's no longer left, like if it goes idle, it says, okay, set your speed to 0, set your state to this. And that covers all the animations that is needed, right? So like I said, my player input is literally just a get access vector, normalize it, and then I can call an attack. There's really nothing special there. Attack is literally just Animator play a string named variable. So like I said, from this one, when it changes those states, it changes this variable to be whatever word, right? So I've defaulted it to weapon sight down, but as this state changes, this value changes, and then when it plays, it's going to play whichever it is, right? Like, and if I hit play, you can actually watch that. So he's down. Let's move our player over. Oh, he's doing an attack. So he's now on the sides, right? If I try to move, see how this one's changing? So he's changing because this guy is telling the system to run differently, right? He's like, oh, we're facing this way. Oh, we're facing this way. Right? And if we move and he doesn't change for a while, you know, that's kind of what happens. So the rest of this, like, so in the init we're telling his rotation to not update, don't rotate him. We're telling his up axis to not do anything. So that's garbage. This one here this is kind of like a check. So we're taking our position and our AI's position, we're subtracting them, getting our difference, and moving our AI back, which I don't think we actually need to do since we're not updating our position. We're not updating our position. Like if I turn this one off, I think that was the right one, was it? Because this method's only needed when you decouple that Navmesh agent, right? Oh yeah, so okay, see how his agent's going there? Because his agent has various speeds, and he's going to move at different speeds, plus he can be knocked around. But the agent's here, so as far as the agent's concerned, we don't have to move. He has no velocity, so this guy's sitting way the hell over here. He's like, wait, what the hell? Right? And if I move, like the agent wants to chase me, but he's only going where the agent is. He's trying to do what the agent's telling him to do, right? Which is why, you know, now he's facing like the wrong way. It's all screwed up, right? So that's why we have this one. That tells the agent to sit right frickin' there, don't move, right? And then we're just taking the agent velocity and shipping it up to that first FSM. And that's pretty much it, though. I mean, in reality, it's pretty simple. But being Navmesh, it's just nice because there's a lot of different things you can do. But I mean, it works pretty good, right? I'm really gonna change that color. But yeah, so there we have 2D top-down AI that kind of using Navmesh that attacks. That's pretty good. I'll talk to you guys later.